Hello everyone, how are you? Do you have my voice? Good morning. Okay, nice. Actually, this class is including IT students, and only five one is attended to the class, and I was waiting for attending the other student to the class. Anyway, I tried to record the session, but I think it's wrong way uh, because when you don't attend to the class and sometimes you have some questions, then you can ask me, and your problem will not be solved. Anyway, today, as the university declared to us, today only we will have half of day as official, and the holiday will start at afternoon, and then we have 2 hour class. But I prefer to have it as online because, as I said, university will be closed afternoon. So today, as I promised you, I start to coding of AVR. I explained about the input-output ports, different registers, and today we want to have the input-output ports programming examples. The examples, as you see, let me find the cursor. Where is the cursor? Okay, I couldn't find the cursor because it is actually eliminated from toolbar. If I find it, I can activate it. Okay, do you see the cursor? Okay, nice. As you see, the example wants us to write a program, wants us to write a program to read the data from port D and put it in port B. As you remember, previous session, we talked about in this issue in detail, and we said that for reading data from one port, we need to configure it as input or output. Do you remember? For reading data from a port, we need to configure that port as input or output. Do you remember? Okay, as we discussed, for reading data from a port or one of the pins or some of the pins of a port, we need to configure that port as input. For configuring the port pins as input and output, we use DDR register. Here we want to configure port D as input. Then we use DDR-D register. And we said that for determining the port pins or bits as input, all of the bits or the bits that we want to configure as input should be written as logic 0. Then, as you see here, each of the registers are including 8 bits. I use the hexadecimal number prefix and 20 because as we talked about it, each of the zeros, meaning that how many zeros about hexadecimal numbers? Each of the zeros actually are including a 40 when we are trying to convert it as binary numbers. Anyway, I'm starting from first statement. For writing a program, as you remember, we said that we need to initialize it by preprocessors. The preprocessor is starting with number sign, then include term, and then header file related to the different libraries. Here we are using Atmega 16, and then the library related to, or header file related to the Atmega 16 is added to our preprocessor. We write number sign, include, then inside less than and greater than sign, we write mega 16.h. However, if we want to use mega 32 at mega 32 instead of mega 16.h, we use mega 32.h. We said that every C program has at least one function, and that is main function. You see here we have our main function, which is which type main function? Void type. Void main, and the argument is void. Also inside the parentheses, curly braces is opened, curly braces is closed. So we said that we want to read the data port of data of port D, and to do that, we said that we need to configure port D as input, and for configuring a port as input, we use DDR register. Here, D port should be configured as input. Then, as you see here, I wrote DDRD equal 0x00 semicolon. Each of zeros, these zeros are including 4 zeros, meaning that all of 8 bits of DDR register is written as are written as 0. But because I used the prefix related to hexadecimal, then I used 00. It's better to have a review about logic circuit and logic numbers, and converting binary numbers to hexadecimal, and different numbers to binary to hexa, and normal decimal numbers to each other, because in next sessions we need to have these conversions. So we usually after the configuring register as input, we usually try to activate pull-up register, and to do that we use port register. As you see, port D is equal for activating pull-up register. We should write the bits related to that port equal 1. Then, as you see, I wrote port D is equal 0x double F. Double F means what? In hexadecimal numbers, double F means what? Meaning that if I want to write here 0b, meaning that binary number, here I should write which number? Are you in class? How many ones? I mean, how many ones? Very nice. Thank you very much. Yes. If we want to write the number in terms of binary numbers, meaning that by using 0b here, we should write, instead of each of ones here, each of f's, we should write 4 ones. Because each of these registers, as I explained previous session, are including 8 bits. Anyway, it's better to that you had a review about previous session to be to understand more the programs this session. Anyway, I continue the programming. Then, as you see here, by using DDR deregister, I configured our port as input because we want to read the port D register data. Then I activated pull-up register after configuring it as output by using DDR register. I activate pull-up register by using port D register. And I wrote for all of the bits logic 1, and by using hexadecimal number, I wrote 0x, double F, and semicolon. Don't forget to write a semicolon. Then we need to put the data in port B, and to putting data in port B, we need to configure port B as output. For configuring port B, all of the bits, we need to configure it as output, and to do that, we need to use DDR register, but for port B. As you see, DDR B is equal 0x double F. For configuring each port as output, we should write all of the bits of that port logic 1. And here, as you see, by using 0x double F, actually, I wrote for all of the bits logic 1. Then you see that we configured port D as input. We configured port B as output, and now we need to read the data. For reading data, we use which register? Do you remember? For reading data, we use pin register. So as you see, I use the while 1. When we are using 1 inside the parentheses, what does it mean? It means that we are creating infinite unconditional loop. Infinite unconditional loop. No, it's not function, it is control statement. While is control statement, and it's used for creating loop. But when we are writing 1 inside parentheses, we are basically creating an infinite unconditional loop. Again, we should have curly braces open and curly braces closed for a while. Okay, wait for 5 minutes, then after 5 minutes, we continue our discussion. Thank you. Hello again. Do you have my voice? Do you have my voice? Is it clear? Are you there? Okay, then we can continue our session. Uh, as I said, at first we configured port D as input because we want to read its data. Then we activated its pull-up register by using a port D register. Then because we want to put the data in port B, we need to configure it as output, and to do that, we should write all the bits values by logic 1, and we wrote it by using hexadecimal number, and we said that double F means 8 ones. And then for reading data from port B, we need to use a pin register. And as you see, I directly read the data from port D and put it in port B. We said that equal sign is actually is assignment operator, as you remember, assignment operator, and actually assigns values from right side operand to left side operand, meaning that after reading data by pin register from port D, it assigns values of this data to left side operand or inside port B according to to what the example wants us to do. So is it clear? Do you understand? Any question? Do you have any question? Okay. There is another example, wants us to program at mega 16 to complement the contents of port B every 0.5 seconds or so. To do that, again, we need to initialize our codes, and meaning that we need to use our preprocessor for initializing mega 16. At mega 16 because it wants us to program at mega 16. However, if it wants us to program another AVR family, for example, AVR type, for example, at mega 32, instead of mega 16, we use mega 32.h. So this is our preprocessor, including a header file of mega 16. Because in our programming we need to have delay, and our delay is equal 0.5 seconds or half of the second. So we need to have delay. And to do that, we said we need to have the preprocessor related to the header file of delay. So as you see, I wrote number sign include and delay function header file. Because we said that for using delay function in our programming, at first we need to initialize delay function, and by using preprocessor, which is including the header file related to the library of delay, we can do it. So after these two preprocessor, we start to have our function. We said that each program is including at least one function, and it is main function. However, we have more than a main function here, and it is the other function is delay function. However, at first we're starting with our main function. It is void type, void main, void, curly braces open, curly braces closed. So the program wants us to complement the contents of port B. Then we need to configure port B as output. So and then we need to complement its content. For configuring one port as input and or output, we use which register? We use which register? We use DDR register. As you see, I use DDR register, and for configuring it as output, we should write all the bits by logic 1. And because I used a 0x hexadecimal number, I use double F. Each of the F is actually in binary are equivalent with 4 ones. Then, as you see, I configured port B as output DDR-B equals 0x double F semicolon, and when a register is configured as output, we explained about port register. Then port register, when one port bits are configured as output is used. We use port register for what? For determining the initial value of that port. The initial value of port B is 0, and then the initial state is 0, or it is driven low. When we explained that when port X is written as logic 0, then the port is configured. At first, it should be configured as output to initializing its state as 0. I explained about all of them previous session. And then, as you see, it means that by using 00, meaning that all of the bits, all of the 8 bits of port B initial value is equal 0. Again, we use while one unconditional infinite loop. Curly braces is open, curly braces is closed. Port B tilde equal port B semicolon. What does it mean? It means that complements port B contents and then assigns value from right side to left side. After that delay, our delay is 0.5 seconds. And then we said that there are 2 types of delay functions in terms of milli and microseconds. I use milliseconds here. For using a microsecond, we can use here US, but I'm using a millisecond. Then delay 500 millisecond, because of 0.5 seconds or half of a second actually is the same with 500 millisecond. And then the curly braces related to the loop is also closed. So as you see, easily we write the program related to complementing the contents of one port by creating delay also in our program. Any question? Do you have any question? Any question? Okay, thank you, Amen, for your answer. But for the ones who don't have any study about previous session, however, I'm sure that half of the class don't have any information about previous sessions, meaning that input-output programming. I want to explain one more time, and then I'll go to next slide. We started with our preprocessor. We insert a particular header file related to our Mega 16. Then after adding the first processor, because we are using delay, we need to add the preprocessor related to delay function. And as you see, we added the preprocessor related to the delay function. After that, we have our main function, which is void type, because we don't want to return any value to us. Only we want to complement the contents of port B. So for complementing the contents of port B, we need to configure it as output, and by using this code, we configured it as output by using DDR register and by putting all of the bits as a logic 1. And then because we want to complement the content of port B, we need to initialize or initiate its state. I initiate the port B, all of the bits with the initial state equal 0. And then I started my program by using unconditional infinite loop because I want to complement the contents every half of a second. And then I use this code or this loop, and here I use the code related to complementing the contents, meaning that by using tilde equal, actually I complement the port B contents and then assign values from right side to left side operand. And because it wants to have this loop every half of a second, I use delay as this function, delay underline millisecond. The value is equal 500, and the curly braces, one of them is related to while loop, and the other curly braces is related to our void main. The other example wants us to program at Mega 16 to read a number on port A and save it to port B every 1 second if the number is 5. However, this is somehow similar to our previous programs, but it wants us to check the value of read the value of read parameter, and then if it is 5, then save it in port B. At first, we should know that because we want to read the number on port A should be configured as input or output. Please cooperate with class. We want to read the data from port A. It should be configured as input or output. Are you there? Very nice. Thank you, Wyndham. It should be configured as input because for reading data from port, we need to configure it as input. For configuring a port as input, we use which register? For configuring a port as input or output, we use which register? Please help and cooperate with class. I'm waiting for your answer. I explained in previous examples. For configuring a port as input or output, which register should be used? We use DDR register. And for configuring it as input, because we want to read its data, we should write all the bits equal which number? Which logic number? For configuring DDR register as input, DDR-A register as input, we should write all of the bits as which logic number? Amin, Wyndham, are you there? No. For configuring one port as input, we use DDR register. As you see, I used, because I want to configure port A, configure port A as input, I write DDR-A register, and for configuring at input as input, we should write logic 0 for the bits that are configured as input. However, about this question, all the bits of port A is configured as input. Then I wrote 0x00, meaning that all of the bits, all 8 bits values are equal 0. Then we want to save it to port B. Then port B should be configured as input or output. Cooperate with class. Very nice, thank you, Amen. It should be configured as output. And again, for configuring a port as input or output, we should use which register? For configuring. Very nice, Yusuf. DDR register, we should use DDR register. And for configuring it as output, we should write the bits equal which number? If you answer this question, then we can continue our example solution. We want to... No, we don't have any logic number equal 8. For configuring port B as output, we said that we use DDR register, okay? And for input, we said that we write 0. You see that we write 0. For configuring as output, we should write which logic number? We should write all of the bits equal with logic 1. Why you forget the previous sessions discussion? For configuring, good listen to me, for configuring a port as input or output, good listen to me. For configuring a port as input or output, we use DDR register, okay? Now we want to configure it as input only. For configuring it as input in DDR register, we write all the bits equal 0. You see that? I write 00 in binary means 8 zeros. For configuring a port as output, again we use DDR register, DDRB. But now about port B, we want to configure it as output. Then for configuring it as output, we should write all the bits equal with logic 1. And as you see, I wrote double F. Double F means 8 ones, 8 number of ones. All of the 8 registers should be written as ones, which is in a binary. Instead of 0x, we can write 0b, 8 number of ones. Okay, I start from the beginning. Wants us to program at Mega 16 to read number on port A and save it to port B every 1 second if number is 5. We should add the preprocessor related to Mega 16 because we want to program it. Because we have delay every 1 second, then we need to create delay. We should add a processor related to delay function. And delay.h is related to library of or header file of delay. Then, because we want to compare the data of port A with 5, because if the number is 5, then put it or save it in port B. I declare a variable as A or B. You can name it as you want. I declare it as A, but before that, the type of variable should be determined. Unsigned char, I used unsigned char. So because A is I determined different types of variables in previous sessions, and I don't want to go back again to them. Anyway, I declared one variable as unsigned char, semicolon. Again, this is what kind of variable? Local or global? The variable that I declared here is local or global? It was one of the, yes, very nice. Thank you, Amin. It is a global variable because it is determined before main function. Then after that, the main function, it is void type. Curly braces open, curly braces is closed. We said that we need to read the number of port A. Then port A should be configured as input. I configured by using DDR register and by putting 0 for all of the bits equals 0. So port A is configured as input. Again, for preventing from the noises, we said that when we configure a port as input, it's better to activate pull-up register. And to do that, we use port register. Port A equals 0x By putting 1 for all of the bits, actually, we can activate pull-up register. Then we said that port B should be configured as output, and to do that we use again DDR register, but here we use B because we want to configure port B as output DDR-B is equal 0x double F. All of the bits of port DDR-B register should become 1 to determine it as output, and our loop is starting from here by using while one. Curly braces again is open and closed. We have a global variable. We determined it. If A, at first I want to read the data from port A. For reading data from one port, we use which register? Help me, please. For reading data from one port, we use which register? We want to read the data from port A. Pin register, thank you, Amin. Then A equal pin A, meaning that read port A data and put it in variable A that we declared it before main function. If A, this operand is not assignment operand, and actual is arithmetic operator. If A is equal 5, because wants us to compare it, the number of port A or the data of port A that's read with this number. If A is equal 5, then curly braces open. This is if statement. For if statement, we have condition and then we open curly braces and we close it. As you remember, this is the structure of if statement. If A is equal 5, curly braces open, curly braces closed, port B is equal pin A. Why? Because want to save the data of port A in port B. As you see, it assigns the data which is read from port A, and if is equal with 5 in port B, and wants to have delay equal 1 second. 1 second is equal 1000 millisecond, and I use delay, underline millisecond, 1000, curly braces is closed. How many curly braces is opened? 1, 2, 3, and 3 curly braces are closed. If you don't use one of them, your program will not be executed and you will have error in your programming. Any question? As I found you don't have any question, then I'm going to next slide, which is related to blinking LED. The example wants us to program a blinking LED using first bit of port C. As you see here, here we want to have a blinking LED, and by using first bit of port C, then it's not required to configure all of the bits of port C as output. At first, please let me know that first bit of port C should be configured as input or output. First bit of port C, we want to interface with LED, should be configured as input or output. No, I mean, we don't want to read its data. We want to interface with a device, with the LED. It should be configured as output. The index is starting with which number? Do you remember, for example, for first bit, we should use 0 or 1? I explained about it. The index is starting from 0. So at first we need to configure it as output. For configuring a port bit or all of the bits as output or input, we use which register? Again, say please. We use which register for configuring a bit or all of the DDR register? Okay, thank you, Amin. As you see here, I wrote DDR C, port C, dot 0. Why 0? Why 0? Because the first bit of port C is interfaced. First bit of port C is interfaced with our LED. Then only it should be configured as output. I wrote for first bit of port C DDR register logic 1. If we want to configure all of the bits of port C as previous slides, we should write DDRC as you see here. For example, the DDRC equal 0x all of the bits are logic 1, but here because it's mentioned that only the first bit of port C is interfaced with LED, then first bit which is indexed by 0 should be written as logic 1 from DDRC register. So I'm starting from the first statement. It is a preprocessor related to Mega 16. Then because we have blinking LED, meaning that it is turning on and off, then we need to have delay to showing that the duration of turning off of the LED and turning on of the LED. Then we add the preprocessor related to header file of a delay function. Then we have our main function, void main void. Curly braces is open. Port C should be configured as output, but first bit of port C, not all of the bits. Then DDRC dot 0 first bit is equal 1. It is configured as output. And then we should give the 0 volt to port C first bit and to giving the value or initial value for the bit of a port that's configured as output. We use port register. Port 0.0 is equal 0. What does it mean? It means that it is initial value that is configured as output is equal 0. If we write 1, what does it mean? If for port C.0 we write 1 here instead of 0, it means that its initial value is equal 1. Or on the other hand, it has a 5 volts, meaning that the LED is turned on. So now we want to determine it as equals 0, meaning that it has a 0 volt. Then the loop is starting while 1 curly brace on. Port C.0 equal 1. What does it mean? Meaning that turn on the LED, meaning that give 5 volt. The initial value on port C first bit is equal 5 volt. Then create delay, for example, for 500 milliseconds, again change it to 0 volt, because we want to turn off the LED, and again create delay equal 500. Why we are using two delay? First delay is used for showing the turning on, because it is equal 1, meaning that 5 volt. Yes, thank you very much. Because we want to show that the duration that it is turned on and turned off. By giving 1, meaning that turn on the LED and delay for some minutes, some seconds, and again put it by putting 0 for that, for port C.0 register, meaning that turn off, or the voltage is 0, then turn off the LED, and after some milliseconds, again go to first statement, and have infinite repeated loop, and then create a blinking LED. Actually, this session is finished, but I want to go to CodeVision and Proteus to explain about them and simulate the LED in our Proteus. You can have a break for 5 minutes. After 5 minutes, you can join to class. I want to create the screen sharing with you, and maybe it takes 5 minutes. One question. Do you have my screen sharing for the ones who didn't leave the class? Do you see the environment of CodeVision? Okay, okay. After 5 minutes, we start our coding in CodeVision and then simulating LED in Proteus. Only 5 minutes. Okay, are you ready? Okay, a moment, sorry. Okay, at first, I want to explain about code vision and then about the pre-use and converting data or the codes from code vision to a pre-use. I open my code vision. Okay, for creating a project in CodeVision, at first we should go to in toolbar. As you see, this is the toolbar of CodeVision. The first icon is related to the file, new project. Then it asks us, do you want to use Code Wizard? In this step, only I want to have introduction about the Code Vision, and I don't want to use Code Wizard. However, using Code Wizard give us some facilities that I will talk about them in next sessions when we will want to work with the LCD. And in this step, I don't want to use Code Wizard because I want to have introduction about Code Vision, and then I choose no. In this step, we should create the file for our project. I use project one, for example, and open the file. Inside the project folder, I create two folders. I call one of them as code, and meaning that my codes, all programmings of CodeVision should be inside this file or this folder. And the other folder are actually used for my pre-use simulation. I call it as pro, okay? Then inside code, I call one, as you see here, create one file. The name of it is one, and I save it. Then it asks us a question, meaning that to selecting our device. We said that we are working with Atmega 16 or 32. Today I want to use Atmega 16. However, they are the same. All the programming related to the Atmega 16 is the same with 32, as I explained in previous session more about it. There are different families of Atmega here, the AVR here. As you see, a tiny, I explain about them, the different families of AVR, 1890 family and Atmega family. As you see, the different types of Atmega family and the improved type of AVR, which is at X mega. But I want to use Atmega 16. As you see, it is here. I choose it. The information related to this device is given here. All the information, flash size, RAM size, EEPROM size, and other number of timers, all of them are given here. However, as you see, for example, if we want to choose Atmega 32, also it is here. at mega 32. If I want to choose at mega 32, all the device information are here. As you remember, we said that at mega 32 and 16 are the same, only they have a bit difference with each other, and it's related to the flash size. As you see, the flash size in at mega 16, 32, sorry, is equal 32 kilobytes, but about at mega 16, it is 16 kilobytes. There are very small differences between Atmega 16 and 32 that don't affect our programming. So I choose Atmega 16 and then I press OK. Then my actually code path is created. This is the path related to saving my code in desktop project one code, and the name of code, as you remember, I called it as one. So here this is my code. If I press on this icon, current project icon, I can edit its name. For example, you can change the name of the code that you created, but I don't want to change it. You can remove it, and there are some icons that you can use for your created code. I don't want to change my code name, and I want to have it as one. There is another icon here in top of the configure project window, as you see, which is called C compiler. In this window, there are different sections. As you see, our selected chip, which was at mega 16. If we want to change our AVR, we can change from here, but I don't want to change it in first step, meaning that in previous step I choose at mega 16. If you regret from your choosing, you can change it here. But about the clock, because our most of the all of the available AVRs in the market are default, their clock are actually set it as 1 megahertz. Their clock set it as 1 megahertz. Then it should be changed to 1 megahertz and this section. Moreover, in the simulation also environment, the default value for the clock of the AVR is equal 1 megahertz. And then it is better to change it to 1 megahertz. But if you don't change it, for example, in your simulation in Proteus, when you're creating delay equal, for example, 500 milliseconds, and if you don't change it to 1 megahertz, and it would be 8 megahertz as the previous its previous value, then your delay would be more than 500 milliseconds. Then in this step, you should change it to 1 megahertz, because as I said, all of the available AVRs in the market and also in simulation environment, the AVR that we used, their default clock is equal 1 megahertz. So it's not required to do other changes in this section, and then press OK. You see that the code is created. We said that the comments which are given between double slash line or between slash asterisk are actually explanatory, and we can delete or we cannot delete it. These comments are executed by a compiler or not. Are you there? These commands, yes, very nice. We can delete it. Then I delete all of these commands because they are making complicated my code. As you see, I delete it again. But be careful when you're deleting, let me to see you again. When you're deleting these commands, don't delete the curly braces. If you delete unconsciously curly braces, then you will have problem about compiling or executing your code because your code will have error. So as you see, I delete the comments related to the explanatory comments, which are extra explaining the codes, and then I compile my code. There you see that there isn't any error here. There isn't any warning here. For compiling or executing the code, you can use this button in toolbar, or you can go to project and build all. Both of them are doing the same thing. After explaining about code vision, I want to go to Prettius. Usually try to run Prettius by using run it as run as administrator, because some of the Prettius softwares have bug, and the library is not added when you double click on that to open it. Then I usually use run as administrator. Then it is opened. So again, we need to create a project in Prettius environment. Please install Prettius and CodeVision, because after this we will have the coding, and also your final exam is in terms of coding, and it would be as a face-to-face in the university. You should have sufficient information about coding and also simulating your codes in Prettius, and also writing the code in CodeVision. Anyway, again, we need to create a new project in Prettius too. We in the toolbar by pushing file button, new project, waiting for creating new project. Okay, here we wants us to browse the path of saving our project. As you remember, in first step, when I was creating the code related to CodeVision, inside project one, I created two files. One of them was code and the other was pro, and I said that I use this file for Prettius project. Then I select this folder, and then I again name the project of that I created in Prettius as one, and next, and finish. This is the environment related to the Prettius. You can use the different components in the toolbar. You can use zoom in, for example, as you see here, or zoom out by using this icon. In left hand, as you see here, in left hand there are different components. You can use this selection mode for choosing the component that you put in the environment. There is a component mode. The yellow component under cursor sign or selection mode, as you see. By this icon, you can, and using this icon, P icon, you can choose different components from the library of Proteus and put it in this environment. Also, you have the icon related to the terminal modes. By choosing this icon, as you see, different terminals, input, output, power, ground, you can choose different terminals and put in your Proteus environment. And also there are different other icons that in next session, when we need them, I'll explain about them. Moreover, you can see there are rotation icons by using these icons, and also these two icons you can have no, sorry, these two icons is related to undo changes and redo changes, but these two icons is related to the rotating the components in Proteus environment. So now I want to create a blinking LED, and to do that I need AVR. Which kind of AVR? At Mega 16, because in the codes I want to use at Mega 16, and also I need an LED. So from here, component mode, good, listen to me. Left hand component mode, I press this icon, and then P icon. There is a keyboard option by typing at Mega. By only typing some letters of the components that you want to choose it, the library help you to choose your desired component. I want to use at Mega 16, as you see here. Moreover, you can write the whole component name at Mega 16. As you see, at Mega 16 is the first icon that's shown here. I choose this one. By a double click on that, by double click on at Mega 16, it is actually transferred to here. You see that. Moreover, I need what? I need LED. I need LED. I wrote LED. By using one dash, the different types of LEDs are shown here. I choose green LED, this one. And by double click on that, again, it is moved to here. In your Proteus library, you choose actually green LED, and it is moved to here to can use in your Proteus simulation. Then I said that we need two icons, two components, and I choose my both of the components at Mega 16 and LED, and then I press OK. So by a click on each of these components, I can put it in my Proteus environment. Again, I want to put LED in my Proteus environment. I click on LED and put it here. We can rotate it by choosing these options. We can change its direction, or there is another option. I want to delete it and use that option. I click on LED green, okay, and come here. By using these two rotating option, I can rotate it as direction that I desire. So then after changing its rotation in this step, I put it here. Why I put the LED in this side? Because in our program, as you remember, let me go to my programming. It is not here. Okay. The last program was related to blinking LED, as you remember, and we interfaced the LED with which port C, which bit, first bit, or bit 0. Then in my simulation, I put the LED near to port C. This is port C. As you see, this is our AVR at Mega 16. At first, I want to explain about it, then go to the next part of the simulation. It's including different, how many ports? Do you remember? At Mega 16 or 32 is including how many ports? At Mega 16 or 32 is including how many ports? Are you there? As we talked it more, and as we had midterm exam in previous session, I expect you that answer these questions in half of a second, because you have sufficient information about architecture of at Mega 16 or 32. What does it mean? At Mega 16, are you there? Do you have my voice? Do you have my voice? Okay. At Mega 16 or 32 is including 4 ports. Port A, port B, port C, port D. Each of the ports are including how many pins? Each of ports, yes, 8 pins. And as you see here, this is our at Mega 16. We choose it. It is including how many ports? Port A, port B, port C, and port D. Each of ports are including how many pins? As we said, I can't see your message. Sorry. Each of the ports are including 8 bits, as you see. For example, port A 0, 1, 2, 3, 4, 5, 6, 7. Then it is including 8 pins. As you see, the figure related to the at Mega 16 or 32 in previous simulation environment is somehow different with the data sheet that we talked about it, but the pins numbers, the pins names is exactly with the data sheet or the figures that we talked in our lectures. For example, in our lectures, port A is placed in right side, But in a simulation in Proteus, you see that the figure related to the Atmega 16 is as this one. But anyway, the name of the ports and their tasks are the same. By using datasheet, you can choose and you can correspond the figure related to the datasheet and the figure related to the simulation. Anyway, we said that in our coding, we interfaced LED with what? With port C, 0 bit. Now I want to check port C. Port C is placed in this side, and 0 bit is 22 bit 22. As you see, a PC0. Then we should interface LED, our LED with PC0. To do that, I use my connection, as you see, but we need to connect the other side of LED to ground. We said that we use terminal mode by using this icon, and I choose a ground and put my ground here. You see, I want to delete ground and to choose the option related to the rotation. Again, the ground, and I rotate it in my desired side. I rotate it and I put it here, for example. And again, I start to wiring, and then it is finished. Now only it's required to do what? To convert my codes to AVR. But in CodeVision, I didn't write any code. Then we have our codes in our lecture. I can copy and paste in to my CodeVision. But before that, as you see here, my code, when I was creating a code in CodeVision, the preprocessor, one preprocessor added to my code. It is a number sign include and io.h. As you remember, when we were starting to our coding, we choose which AVR. Do you remember when we start to our coding in CodeVision, we choose which AVR, which type of AVR? Oh, Atmega 16, very nice. Thank you, Amen, for your cooperating. But you see here in our coding, let me go to my coding, at Mega 16 or Mega 16.h is not added to my coding. Actually, you see io.h. Actually, this header file is including all of AVR families, A-Tiny, at Mega, at X Mega, and all of the types of each family, meaning that it is a general header file, feeder file, and actually it is including at Mega 16 inside itself. So I want to go to my coding that I explained about it. We write this coding for blinking LED. Now, this is not required to add to my codes because we said that io.h, the ones who are sending me, yes, the delay should be added by ourselves. Actually, this preprocessor is added by CodeVision, okay? But you see that we don't have any preprocessor related to delay. Then we should add it by writing a code. And I want to add it right now. Wait. this is our code that we write. This one is added by CodeVision, the general mode, io.h, which we said that it is including Mega16.h. Then we should add the other part of our codes. Because I wrote it here, I wrote these codes and I explained about them, then it's not required to write it again in our CodeVision, and I can copy it. Why it's doing like that? Because I didn't use a mouse. Okay. I delete all of them and paste my code here because I wrote it, I have it, and it's not required to write it again. Okay, you see that this one is added by my CodeVision, by the CodeVision. I added the preprocessor related to the delay, and I started to write the code. However, this part, if I want to use Control Z, you see that this part is added by CodeVision, and only it's required to write the codes after that. But because I use the delete option, then I should paste all of the codes that I wrote in my programming for blinking LED. Include delay, void main void, ddrc.0 equals 0, port c.0 equals 0, while 1, and so on. All of them are added to my CodeVision as you see here. And then I compile it. You see that there isn't any errors, or we said that we can use project and build all. Both of them are the same. My codes don't have any error. And then after that, I'll going to my Proteus, and it's required to transfer my code from CodeVision to Proteus and to inside my AVR. This is my AVR. By right-click on that and edit properties, I can choose the file related to the code in CodeVision. Desktop, project, the name of the file that I use for both code and pro was project, then code, debug, exe, hex1, and okay. Then all of the codes that we wrote in our CodeVision is converted to my AVR at Mega16. Or there is another way to transferring the codes from CodeVision to Produce by double click on my code, my AVR, and again from here we should go to the file that we created at first. Again, code, debug, exe, one hex, and okay. So we can run our Proteus simulation by using this icon. And you can see that we have blinking LED. As you see, all of the pins related to port A, B, C, D, except PC0 are gray. It means that all of these pins or all of these bits as default are as input. Then gray means that that pins or bits is as input. But port C0 or first bit of port C is blue and red. When it's when it is blue, it means that it is turned off, or it is initial value is equal 0, or 0 volt is on that. When it is red, it means that its initial value, it is as output. At first it is as output, and also when it is red, means that its initial value is equal 5 volt. As you see, when it is red, the LED is turned on. When it is blue, the LED is turned off. Then red and blue color for the pins means that it is defined as, or configured as, output. But different color related to blue and red means that the output initial value is 0 when it is blue, and the output initial value is 1 or 5 volt when it is red. As you see, this is we created a LED which is blinking, and we can stop our simulation. Again, I want to go to my codes. We can increase the value of delay. Let me to check. I'm checking it for my first time. And again, go to Pretuse to see the result. I think the delay that I created is too much. Yes. The delay that I created is equal 10,000 milliseconds, and then we should wait for turning on and turning off of LED. The duration for turning on and turning off time is equal 10,000 milliseconds. Any question? Do you have any question? Okay. Okay, thank you very much. If you don't have question, then I can finish the course. Thank you very much. Yes, it would be face-to-face and also practical, meaning that by practical, I mean that you will do the same things that I'm doing here in CodeVision and Pretuse softwares. You write the code and then transfer it to CodeVision to Pretuse, and then simulate it in Pretuse. Thank you, Amin. Thank you for your cooperation in the class, and thank you for the others that are cooperating. Next week, we will continue our discussion again with coding and simulating in Pretuse and CodeVision by using another device for interfacing to our AVR at Mega 16 or 32. Thank you very much. Have a nice time, and iyi bayramlar. Bye bye.